Alrighty, hello everybody, and welcome back to the channel. Let's see, what are we doing today? Today we are going to be building a fish finder. So, let's see. Depending on how this video goes, we will make a compact fish finder. And then, if that goes good, I will then, we'll then expand on that and we'll make a bigger one. Okay, so the first thing we need is a ship. So I was just using that one to learn from. Let me load up a ship here. What do we got? Way too many, way too many, way too many. Where's my... I just need a ship that works. The base engines are broken currently. I'm sure they'll fix that. I don't think the modular engines are broken, but the base engines are broken. So I'm just looking for... Oh my goodness, I got way too many. Way too many of these. Where is it here? Not that one. This one here. Alright, this is my newbie starter ship. Okay, so the first thing we need is the fish finder. Alright, so we're going to put that on the bottom of the boat. So it goes in the water. Alright. The second thing we are going to need is a monitor. For this example, I'm going to be building a compact fish finder. So it's just going to be on one block, okay? And then the last thing we need is a microcontroller. So if you don't have a microcontroller... that's the editor. Can I make a new microcontroller? Alright, I just make a new microcontroller. What is this? 2x2? So what is a microcontroller? A microcontroller, think of it essentially as a computer chip. Alright, so if you have multiple functions that you want to add into your build, microcontrollers are the way to do that. You can merge signals. You can expand signals. It's mostly used for composite and things like that. Okay, so what we want here is just a 2x2. So we need composite. We need a video node, and then we need one more, which is going to be our speed. All right. Video is going to be output. Then we're going to go into the logic. Input, output, okay. Then we need a Lua block. What is a Lua block? A Lua block allows us to code. This is where we're going to add code for our fish finder. So the other thing we also need is, if we type in composite, we need a composite read number. No, we need a composite write number. And this is going to come in on channel, let's say channel, oh no, it's going to have one channel, let's say channel 5. Alright, and now what we can do is we can take this input from the fish finder and we can actually bridge it right through into here. Now the fish finder actually is 8 targets. Hold on a second here. It's 8 targets. So let's change this channel to, I don't know, let's just choose channel 20 for example, and that way we won't have any interference coming from the fish finder, okay? And then we're going to connect our video output. This is going to go to our monitor. So before we get into the coding, we're going to save this, and we're going to save this as fish, as our fish finder. Perfect. Then if we exit this and we go into, we press tab, and we type in fish finder. Okay, where? Uh-oh. Oh, did I save? It'll be here somewhere. Blank, blank, RCS, microcontroller. Oh, what? This is not starting out good. Where did it save it? Alright, I don't think it actually saved it. So let's go back into the microcontroller editor. And yeah, there it is right there as the fish finder. So why can't I find it if I type in fish? spaceship, uranium. Okay, hold on. Let's go back in here and then. Yeah, if I load the fish finder. Alright, well, let's give it a symbol then. Let's just give it a symbol. So I can find it here. Like that maybe, and then, I don't know, let's see here. Some kind of fish. 1, 2, 3, 4. We'll do that, and then an eyeball. Okay, perfect. There's our fish finder, and then we'll save this as fish finder. Yes. Now, if I exit out of here and I type in fish, it should come up, and I don't understand. Maybe if I type up micro. There we go. It's just saved as microcontroller. Okay, I have to change the name. All right. So there's our fish finder. And then what we want to do is we want to take our composite in. Oh, the other thing we need a toggle button to turn our fish finder on and off, and we need a keypad. Keypad is going to be our speed, and I will explain that when we add the code. So, click on video. Video goes to the monitor. Click on data, fish finder, and this here. Alright, then we're going to go to electricity. I think there's electricity on this boat. Yes. Connect the fish finder, toggle button, monitor, and the keypad. Alright? And it doesn't matter. We don't need the backlight right now. Okay. So let's get right into it. Now we're going to add the code. So, before we add the code, let me just look at one thing. If we click on composite and we hover our mouse over the fish data, we can see that input 1 is the angle and 2 is the distance. All right, 1 angle, 2 is the distance. Now we need that. That's per target, and then 3 is the depth. All right, but we won't worry about depth right now. We're just going to worry about the angle, and we're going to worry about the distance. All right, and now the code that we're going to be doing, this works for the radar as well. So what I'll do is later on this week, I'll put out a better radar tutorial. Okay, so the first thing we're going to do is we're going to delete all the code that's in there, and we are going to make our own code. So the first thing we want is a couple of variables, and we're going to say width, all right, equals 32. This is the size of the monitor. It's 32 by 32 is the base one. All right, then A equals 0. We're going to be using that. It's just a variable for our circle. Okay, then we need I was going to say speed, but we don't. We need our max distance. We're going to set this to 100. Which is 100 meters, right? Every number is a meter. And then we need this fancy right here, targets. Oops. Now what that does is this is going to allow us to create, it's going to allow the code to create an imaginary file folder, which is going to save the XY values of the targets, and then we're going to recall that data and print it. I know, it sounds really fancy, right? So the first thing we're going to do is we're going to go function on tick, like that, all right? And then we want to say target equals, and we want to say input dot get bool, all right? And that's going to be channel number 1. And then we want to say distance equals input dot get number, and I believe distance was channel 2. All right, and then we need our angle. Angle equals input dot get number, and this is going to be channel 1. Notice the difference. Boolean is true and false. Number is number, and so on and so forth. So this is the one thing I love about this game, is that you can really expand on this. And if you're getting confused with your inputs, you can just quickly write up a script. And that script can handle all your inputs and everything for you. It's really neat. All right. So now we need our distance pixel. So this is how we're going to convert the distance into a scale that we can print. All right, so this is going to equal, inside the parentheses, we're going to say distance divided by max distance, and then we're going to multiply that by the radius, which in this case is 16, because our diameter is 32. The radius is half of the diameter. So we're taking the distance of the fish, we're dividing it by our maximum distance, and we're multiplying it by the radius. So that will allow us to print it within the radius. So if you want, yeah, that's basically the easiest way to explain this. When I go over the radar, I can explain the max distance in further detail, but essentially the max distance is the distance you want to set your ability to detect the targets. And then it will scale that and print that inside the radius, however big you want that radius to be, and it will always scale it that way, which I think is really neat. The other part of that I don't have yet is the map scale. I'm getting close to figuring that out. When I figure that out, we'll get that. Okay? So next we need is the A variable that we created, and we're going to say A equals A plus speed. Now, what do we need this for? We're going to be creating a circle, and then inside that circle, we're going to be creating a line. And we want that line to spin around, similar to a radar. And that's what we're creating right now, is we're creating the variables for the line. So we're going to say if A is greater than or equal to 0.5, 0.5, then, so basically if you do a full revolution, it goes from negative 0.5 to plus 0.5. We're going to say A equals not 0.5. So basically it's going to reset itself. Once it's done a full revolution, it resets itself and then it spins again. Right? This is how we're able to give we're basically giving we're giving rotation to the line. Okay, without this code, the line won't rotate, and we'll need to measure something else to get the line to rotate. So we either measure a velocity or we measure a number, and we give that number of velocity for the line. All right, and then we just say end. Perfect. And now we're going to say radar A, which is just a variable, equals, now here we get some fancy math. So what we need to do is we need to convert this line into we need to convert it into degrees. So basically we're making a compass, right? So in order to do that, we need to go A plus 0.5. All right, and then we need to multiply that by 360, which is a circle. All right, and then what we need to do is we need to multiply that by math.pi, right? We need to multiply it by pi and divide by 180. And that right there is how radar A could be anything, but we're taking it and we're turning it into degrees so we can gauge where it is within our radius. All right, so now we need a couple of variables. We need x1, we need y1, we need x2, and we need y2. All right, x1 equals, and we're going to say the width divided by 2, and then we're going to add the radius to it, and we're going to multiply that, all right, by math.cosine. And then we're going to multiply it by the angle, which we need the degrees, 1.58 plus radar A. Okay, so let me explain this number, 1.58. So well, you take a circle and you have 360 degrees in the circle. Well, every degree is 1.58. That's 1 degree. So in this case, unlike the angle, it already gives us the degree to turn, okay? But in this case, we don't have that. So we have to add 1 degree to our line to tell it where to go. All right, and then essentially we're going to do this, and then we go height divided by 2, and then we just add the radius, right, plus 16, and then we say math.sine times math dot, basically sine angle, all right? And then we go 1.58 plus radar. All right, so where do you have a point, 0, 0, and you have a destination, AB, and you want to find where AB is, this is what you do. You take the radius, right? Your starting point here is the center of the screen, and then to find that endpoint, we do go math cosine angle or math sine angle, right? That's what we need. Math cosine angle gives us X. Math sine angle gives us Y. All right? Pretty easy math. Okay, so then we need to do the same thing for here. X2 and Y2, this is going to be the target. All right, so this X1 and Y1 is going to be our line, and now we're giving the target. So this is going to be a little bit different. Now this one here, we're going to add the distance pixel. All right, and then we're going to multiply that by math dot cosine. And the cosine, you need to multiply it by the angle. And in this case, they give us the angle already, which is input number 1. So we can just copy that. And we can say h divided by 2. Oops. Divided by 2. Plus, and then there you go. Except instead of cosine, we want to say sine, right? Cosine is x. Sine is y. And if you looked at I looked it up. All right. Now what we're going to do next is we're going to program the code for the targets. So we say if targets, then, and we're going to say targets, and then these little guys, and we're going to say x2, all right, equals y2, just like that, and just like that. Now this next part here is where we set up the, okay, so now we've created the folder. So every time there's a target, it's going to add that target to the folder. So the next part here is we're going to be able to clear the radar. So for this example, I'm going to clear the radar whenever our line does a full rotation. Later on, when I design the larger fish finder, I'll probably have a button or a timer instead, or I might, whatever, right? But this is where our speed is going to come into fact. Well, actually, yeah, you know what? We need this here. We need speed equals input dot get number, and I think we made it channel 20. Let me check real quick here. Channel 20. Okay, so that's what we're going to read. Speed input get number channel 20. Okay. All right, so we'll say if radar A is equal to 0, then, and we say for I in pairs, all right, and we want to say targets, which is the folder, do, and then now it's going to search through the folder. We can say targets, and then if we say, we put the I in here, then instead of, it'll just go through the whole folder, and it'll clear the whole folder. It'll look for all the instances, and then we say nil, all right? And so what you're going to say is, well, wait a minute. If a full rotation is 0.5, then why are we resetting it at 0? Now, I've tried to reset it at 0.5. I've tried to reset it sooner, and for some reason the code just doesn't want to work. So unfortunately, the first rotation, we only get half of a rotation, and then it clears. And then after that, we'll be getting full rotations from 0. It's just I've been playing around with it. Maybe there's a different way. All right, so we want to end, and then we need 3 ends here. Oh, targets channel 5. Global targets. Oh, am I using the wrong? I think I'm using the wrong brackets here for that. No, I don't think so. Oh, is it target channel? All right, attempt to call nil value. Whoops. That's probably why. Yeah, there we go. I forgot to add the equals in there. So we need to add the equals in there. Okay, perfect. Let's carry on. So now we do the on draw. So we say function on draw. Okay, now how does on draw work? Well, on draw works, it's going to draw everything onto the screen. But it will draw it, so first it draws this item, then it draws this item, and this item, and this item. So this is where it's kind of important to think about the layers that you want on the screen. Right? Because anything you draw here, if you draw something else, it could potentially draw it over top of what you want. So when we do the bigger, larger radar, I'll expand on that. We might get into that in this video. I'm not sure. Okay. So we just say W equals, and we can say screen. Actually, I don't even think I need those 2 variables here. All right. So we'll say screen. We want to set the color of the screen. So if we go into help here, and we go to set the color of the screen, we can just copy that. Just paste that function into there, and I already have a color set up. What is it here? 176 224 230. I think that's just off white here. And then we want to say, oh yes, then we're going to draw a circle. Yeah, that's the off white, and then we want to draw a circle. So to draw the circle, we need X, Y, and the radius. So the x and the y would be w divided by 2. Whoops. W divided by 2, and this should be h divided by 2. And then the radius is going to be, the screen is 32. So we'll see how that looks. I might, oh no. The radius has to be 16, because the radius is half the diameter. My bad. Okay, now we're going to draw a line. Same thing, we go to help here, and we want to draw a line. Draw color, draw line, screen.draw line. So we need, now you notice here, we have 4 values that we need. X1 and 2, and Y1 and 2. So this brings us back to this example. So now our X1 is going to be the center of the screen, which is the width divided by 2, the height divided by 2, and then our X, we need X1 and Y1, which is this first bit here, right? This handles the line here, okay? And then, so let's just stop there. Can I do that? Yeah, let's just stop there, and we'll see what I have printed on the screen so far. So I'll spawn this in. Let's see, I will turn that down there just for the purpose of this tutorial. Okay, so when we turn it on, oops, probably help if I connected all the logic here. We'll connect that to there, and whatever, we'll connect that to the backlight. Okay, now we'll spawn it. Yeah, this boat kind of works, but it has 2 of the base engines in it. I think the modular engines don't have the ATM issue. What's the error? Global get number. Oops, that's my fault. I made a mistake in the code. So we'll go back in and we'll take a look at the code. Input dot get number. There we go. Update that. Spawn that in. So now I should have a white circle and a line on the screen, and they're not going to be doing anything. Global speed. Oh, whoops. Right here. Speed. That's what happens when you write down your code and then you decide to change it on the fly, but you don't tell yourself that you're changing it, and you just look at the code that you have there. Okay, there we go. So we have our line and we have our radius and nothing else, and it's not moving, right? But if I set this to 0.003, hey, our radius starts to move. Neat, huh? Okay. Fancy. So now what we need to do is we need to handle the printing of the targets. So we are going to say for with instance, which is the instance, and then the variable, which happens to be x2. Okay, in pairs, and then pairs is, we name the folder targets. All right, so it's going to search through this folder, and it's going to look for the instance, which is targets, and then it's going to look for the value, which is x2, and then it's going to print that value on the screen. That's basically what we're doing right now. And then we want to screen dot set color. Oops. So what we're doing is we're setting the color of the dot, and that's red. 200.00 is red, and then we're going to go screen dot draw circle, circle. All right, and then now we need the same thing. So I just go I, V, and then the radius, right? So this is X and Y, and then the radius. I'll do radius of 1, so it's nice and small. Perfect. And then we say end. Okay, and that should be that. If we update that, alrighty, and then we spawn this in. I'm going to sail out a little bit, and then I'm going to turn on the fish finder, and it should start detecting fish. So turn the engine on, start. Come out a little bit here. Whoa! Alright, just come out this far. Ah, global screen. No, I made a mistake. Oh my goodness. Where? Right there. Oh, let's try that again. Here, I'll turn it on this time before I sail out a little bit there. Just in case I get too far and I'm not able to, let's see. Let's now field deer circle. No, draw circle. It's good to know I can spell. Oh boy. R-A-W, draw circle. No errors detected. But what I find is that you can search, it'll say no errors detected there, and then when you actually spawn it into the game, if there's errors in the code, it'll say, all right, and there we go. So now there isn't a fish below us, but for some reason it likes to draw that first circle. I don't know. I haven't quite figured that part out yet. Okay, so we'll start this up here. We're going to go forwards a little bit. Okay, and now fish should start to appear on the fish finder, and it should save their positions. We might have to wait for some fish to spawn, actually. Check the settings, make sure wildlife is on. Yeah, wildlife is enabled. Oh, there we go. There's a fish. Alright, so let's just do this. So now the radar's ability to detect objects is not dependent on the spinning. Okay, all the spinning does is give us, it'll clear it. That's all the spinning does. So now we're basically just waiting for the fish finder to detect a fish. So that's what I was saying. This part here is kind of where hopefully the developers are going to update it a little bit and make the fish finder a little more sensitive than it is here. But what I'll do is let's clear it. Let's just clear it. We'll do that, and then it'll clear it, and then we can set it to 0. So now it's cleared. We can even slow that down. We can say like 00003 if we want to, or 1001. Maybe that's a bit... Yeah, you see how slow that's going? Oh, there we go. There's a fish. Excellent. Okay? And any of the other fish that pop up... Oh, there's another fish there. It could have been 2 fish. Neat, huh? And then if we want to reset it... we just tell it to rotate. Oh, there's another fish. Just like that. Oh, there's some more fish. And more fish right over here. Okay. So now the radar, yeah, they're right over there. That's cool. Radar is going to work exactly the same, where we're able to print targets. Like, I finally figured out how to get all this to work, and I'm really excited. So I'm going to be updating the radar. But that's it. Now we have a compact fish finder, and it's accurate and it scales. The white line is our maximum distance. So anything inside that distance, and this is accurately scaled, right? It detects objects up to 100 meters away. So these are accurately scaled to within 100 meters. So we can say, wow, there's a cluster of fish over there. So we can go over there, wherever that is, probably right over here. And yeah, get those fish. So yeah, that's it. That's our compact fish finder. So I hope you guys found this informative. And I know it's really basic. But that's it. It really doesn't get any more complicated than that. And now for this, you could put this on a timer if you want to. In the microcontroller, you can add a speed. In the Lua script, you can add a speed if you want. I just, while I was doing it, I thought maybe I would add the keypad. And this will work the same thing for radar. You just have to switch the inputs around for the radar because the angle and the distance is different. But that's it. That's it. Yeah. So anyways, thank you so much for liking. Yeah. Thank you so much for watching our little fish, our custom fish finder. And then the next thing you could do, so now that we know our maximum scale, which is our radius, so that what we can do after this is if we want to add more lines to it, let's say we wanted like a different line, then all we need to do is here where we say draw circle. Okay, we can just copy that. All right, and instead of the radius being 16, we can make the radius 8. And now if we were to scale that, that would be 50 meters. So the outside line is 100 meters. This inside line would be 50 meters. There we go. And now we could tell we have a more accurate way of being able to scale our fish finder. Wonderful. So let's see, where are we at? Wow, that was only 30 minutes. Okay, I guess that was good for this tutorial. What I could do next is we could take a monitor, like a 3x3 for example. And then what we can do is we can actually expand on where we want the fish finder to be. The fish finder, no, we can determine, what am I trying to, so this is kind of where it gets a little bit more complicated. All right, so here we're taking the radius from the center of the screen. But if we want to have a fish finder, say like the one that we see in all those other YouTube videos, where they have the top down and then they have the side version, we're going to need to offset where we want that circle. So we can just determine instead of, so now okay, for the purpose of this, I'm just gonna do this. Our new monitor is 96, okay, by 96. That's the 3x3 monitor. So we can now say if I want so we're 3 individual monitors wide by 3 individual monitors tall. So if we wanted this in the top left, we would have to say this is 16 and this is 16. I don't know if that's 16 or if that's minus 16, but let's just check that out. Let's update that, and basically now it's just a matter of trying to align it wherever you want it on the monitor. Here, I'll run over there and we'll just take a look at it. Okay. There we go. And now it's there. Now we can make that bigger if we want to, and in this section here, we can add the depth if we want to. We can just raw print the depth. So every time it detects a target, we can raw print the depth, you know? And then in the bottom, we can also do the same thing where we can have it kind of roll sideways, and it can, look at how many targets it's detecting already. Fish all over. Is that like right below us? Oh yeah, because they glitched through the dock there. You know, it's just populating as I'm sitting here. Look at this, it's overpopulating. Whoa, there's a lot of fish over there. Wow, okay. So yeah, so that's sort of, you kind of get the idea. And then it's just a matter of playing around with this. And then, I guess the depth. Okay, so how would we do the depth? How would we accurately gauge the depth? So what we need to do is, we need to draw a line. Okay, so anytime there's a target, let's see. We draw a line, and then we just need the x1, y1 to the x2 and the y2. So let's see, let's just take this right here, and let's change this to, I don't know, let's say 16. Let's go 32, and we'll make this 32, and then our x and our y, that would have to be our depth. So let me see what our depth is coming off of our fish finder here. Because I hadn't really thought about this part yet. Value 3 is our depth from the sensor. So we need to say input right here. We need to say depth equals input dot get number. All right, and we need to say 3. And now we can say, let's see. So our y is going to be our depth, and our x1 I don't want to see how this is going to work first off. I don't know if we can do both in the depth. Like I say, this part is kind of unknown. I'll have to spend a little bit of time thinking about this part of it. I really didn't think I was going to get into this. Oh yeah, there's our line right there. Yeah, that's not going to work because it's printing it inside the radius. We don't want that. We want it to be its own. We want it to be outside of that. So I'd have to do this, and we have to print it up here, I think, outside of that. Is that right? Spawn it here. Oh no, it's still printing. It's still printing. Why is it still printing there? I don't even know. I don't even know. Oh, let's get rid of that. Yeah, because we want to come in 32 and we want to come down 32, and then we want it to print our. I don't know, this part here I'm gonna have to think about. I'll just have to play around with. So I'm really sorry that we didn't get that part into it. Yeah, because basically the text has to roll this way, so I need to find some code which is gonna allow the text to roll that way, and then I just need to figure out how to get that line to print vertically. I know it's Y1. I know Y1 will be the depth. Oops, no, that's not. Let's do that. I know Y1 is going to be the depth. I know that for sure. But I don't know why. Oh! Let me see here. If we say 64 and we say 64, and this, it should expand this way. It should expand like that. And I don't know what the X1 is gonna be. I know I have some code which will, if I just look at another microcontroller, I have the code which can help me with that. Maybe I'll do that. Oh yeah, there's the line there. See, it's coming from here. Let me see. Let me look at a which microcontroller do I have for that? Is it it's our stats, right? Is it this one here? It's this one here. This is from the spaceship. This one's from the spaceship. This gets a little complicated. Draw text box. Is it this one? It's this code here. Draw rectangle F. That's what it is. Draw rectangle F. Yes, that's probably better. Alright, and instead of space, this can be... I don't know, let's try something. I think this one is going to be space. No, this one's going to be depth. Whoops. So we're drawing a rectangle full is basically what we're doing. We're filling it up, and then we're going to try and make it that color. I'm just playing around here basically at this point in time just to see. The way that the code I have it expands horizontally and not vertically. Yeah, so there's the rectangle. So you see... Oh, did you see it disappeared? That's hilarious. So let's set this to so it clears. Oh, neat. I'll let it do one more rotation, and then we'll clear it. So a fish will come up, and then that full rectangle will come up, and it should expand depending on the depth. So now all I need to do is take it and shrink it. Here, let's see. I'll try and explain what I'm talking about. Okay, so first off, we want to get rid of this line here because that's confusing. So this one here, it should expand. Yeah, let me see. What's the rectangle full? I think it's the same thing. X and Y, and then your width and your height. So our X can be 64, and our Y can be 64. So that's over 64 pixels. Down 64 pixels is where it's going to start. And then our width can be, I said 65. Our width can be 2, and then our height is going to be depth. But now what we need to do is we need to multiply that by -1. Because I think at this point in time, it's going to fill up this way, and we want it to fill up that way. So let's just see how that looks. fish right there. He's going to come up on our fish finder. Oh yeah, there. Did you see the white dot? You see that? Perfect. See, it got bigger with the depth. Oh, notice that? It's expanding. All right. So that's kind of the start of it. That's the start of it. There's tons of fish. Every time it shows a fish. So each fish we can either have it tell us the depth, or we can do that where it records the depth this way and we just scale it in a box. And then it just slowly, we set the speed and it slowly rolls this way. But I don't quite know how to get the text to roll. I have to actually go and look at some code, which I haven't actually programmed that into Stormworks yet, so I don't have the code readily available. So I apologize for that. So yeah, that's going to conclude our fish finder demonstration. I hope you found it. Let's just go over it real quickly so we know what we did. All right. First thing we needed was the fish finder. We needed a microcontroller, a monitor, a button, and a keypad. Then, inside our microcontroller, we need a number input, a composite input, and a video out, which goes out to our monitor. Composite, this is in from the fish finder, and this is in from keypad. So that would be speed, right? We can do that, just say. And that's our rotation. Oh, we can even say rotation. All right. Then inside the microcontroller, we needed a composite write number, which allows us to take this number and write it in a composite channel, which we can then read from our Lua script. Then we programmed our code. Remember, we set up our monitor. If you want the radius to be bigger, you can set that to 64 by 64. But remember, if you change the screen size, you have to change the radius, or you have to change the radius, because our diameter is going to change. All right? And then we wrote our code, and our code, and our code. And that was essentially it. And now what I'm trying to determine is this part here, writing the depth as a image rather than numbers. So we can more easily interpret that. Yes. So thank you for, and then like I say, here you can draw color. What I'll do is once I figure this out, I will expand on the 3x3 theme, and we'll try and make this a little bit bigger and better. And when I do that, we'll go over the rest of the code. So yeah, thanks for watching, and I will see you in the next one.